Alrighty. Well, good evening, everyone. My name is Adam Hems. I'm one of the leads of the Houston Azure user group, along with Kim, who stepped out, and her family. Where's Kim? Greetings. Welcome. Welcome. A couple of at least two noobs joined. Yeah, those two there. Another noob. Okay, welcome. New face and some familiar faces. John's first time in person, but you've been here online before, so excellent. Some more noobs over there. Actually, Havinder, greetings. Welcome back. Yes, Havinder's been here before. Yes, welcome. So a warm welcome. For those who are new, Kim and I have been running this for years, long time. Our day jobs involve Azure all day long. I'm ex-Microsoft. Kim is currently with Microsoft. I work for consultancy now, doing, again, Azure all day, every day. And so this is an opportunity really to step away from our day jobs and learn not just from our presenter, but also from each other, right? So communities, a chance to chit chat and learn something in ways outside of what many of us do for our day jobs. We get folks from all over Houston. Any consultants here today? Okay, kind of consulting. We often get consultants because consultants like to learn things. So, that's a common one. Oil and gas, anyone? Okay, oil and gas, yeah, a couple of folks here. Yeah, some oil and gas. Oil and gas, yeah. It's all good. Healthcare. Sometimes get a lot of healthcare folks, state and local government, or some random business here in Houston that might be doing something or other. Or tech. Okay, there you go. Yeah, there's a lot of those, a lot of companies in Houston that does all kinds of stuff. So, because it's a big town. So, Dan, welcome back. Greetings. Yes, many familiar faces, people coming backwards and forwards as well as the noobs. So it's good to see the familiar faces. It's also good to welcome the noobs. Hope you come back. It's a lot of fun. Spend some time chatting to people. It's good. Here to learn. So if you're here to be sold to, you're in the wrong place. Sales pitches don't go down very well. We've actually had that by mistake at least once. It's not good, so that's not going to happen. We're not going to do that. Not going to sell to you or sell to each other because that's, in some cases, our day jobs, and no one's here for that. It's chit-chat learning. We also encourage people who are job hunting. You want to get into the industry of cloud, want to learn about it. We get students coming here. Again, this is the right place to be for that. We encourage recruiters as well. To post job offering jobs that they are trying to fill that involve the tech that we talk about here. Again, not something that would do part of our day jobs ordinarily, right? That's part of our community, what we're looking to do. All right, well, with that, I'm going to hand off to our presenter. Did you want to say anything, Kim? I'm always the one who does all the talking. Yeah, you go.
I want to start with saying that each of us has a purpose, and you're here to invest in yourself to learn. And my purpose is to share the knowledge, to get the expert together to teach us a few things up, tip and tricks and different technology. And happy to share that with you all. But the fact that you're here is deeply appreciated. We share commonality in terms of learning. Perpetual learning, and no matter what's happening in the world, there's layoff, there are flood everywhere. But the fact that you're continuously moving to learn and to keep that passion in you in technology, it's speaking volumes. So thank you for being here.
Thank you, Kim. So one last thing. So everyone here enjoyed some pizza, right? We like to call out a couple of things because we're a community. So Microsoft lets us use the room. That's nice of them. Thank you, Microsoft. And somebody usually covers the food. And tonight it's actually MongoDB who are helping us with the food. So we thank them for feeding us. Thank you. With that, I'm going to hand it over to Paul. Is your mic on, sir?
It should be. Can you hear me? Is it working? Does it make a difference?
Yeah.
Great.
All right. Over to you, sir.
Thank you very much, Adam, for the introduction. Very excited to be here. It takes me back. In fact, when I was getting into .NET, seriously into .NET in 2000, so that I was 5 years old. I joined the .NET user group, and I was very, very invested in the user group. It was very helpful for me when .NET 1.0 came out and the framework and C#. came out, so I had a lot of fun. And in fact, talk about recruiting. I met a gentleman called Jeffrey Palermo, who was he was an MVP, and he turned out to be a mentor of mine. And I learned a lot about software engineering. And I met him on Net User Group, hired him as an IVP of engineering, and we had a lot of fun building software together. So it's kind of fun to be here in this room and giving back, and hopefully I'll be able to deliver some material that can kind of, I'm thinking about brain candy is what I'll be presenting. But before I go into what I'll be presenting, I just want to introduce myself. I gave you a little bit of background. I grew up in Canada. I do have an interesting history where I was doing an internship at my college, and we had this thing where you could go to school for 3 semesters, and then you could work for a company, and you actually had to interview and go through this whole process. And I grew up in Ottawa, and the headquarters for the Royal Canadian Mounted Police is in Ottawa, and they had an internship. So I joined, and this was in the 90s, and they wanted systems to go on the PC side. So they had this interesting system they wanted to build called VICLAS. It was called the Violent Crime Linkage Analysis System. And that's, if you've seen FBI and you've seen VICAP and all those shows, Canada wanted to build a system, but everything was mainframe that existed. The FBI system was on mainframe. They wanted it on PC. I was doing an internship. I said, pick me, coach. I ended up bringing a really, really smart buddy of mine that I was studying with in college. And we built the system, and it ended up going national and international. And then that's what brought me to the US. I was recruited by an investment firm to go do a startup and take some of the technology we had done and do a general purpose. Ironically, it was a document database, which MongoDB is. And if those of you that aren't familiar with Mongo, I'll go into a little more detail. And it was vector search back in the 1990s, 96, 97. So funny to come full circle and be talking about it again, which much more modern technology. So I've done startups in my entire life. And then I had a friend that recruited me to MongoDB because he wanted to build, he was a promoted VP, wanted to build the Azure partnership. He was promoted to do that. We didn't have, we had Azure, Atlas on Azure, but we didn't have a strong partnership with Microsoft. So we're building that relationship. We already had one with AWS, had one with GCP. So he said, come join me. I said, I'll hang out with you for a year. We'll have some fun, because we had a lot of fun. In fact, he was my sales mentor because we hired him as our salesperson out of college when I did that startup. That startup was called InfoGlide. So that's how it came to be at Mongo, and I've been at Mongo so from the inception of the partnership, which has been over about 3.5 years. So that's a little bit about me. I have a very special guest with me, Azim Udin from Microsoft, and I'll let Azim, a good, amazing co-presenter, amazing partner in Thrive with the partnership, but I'll let him introduce himself. He's online.
Sure. Thank you, Paul. You guys can hear me, right?
Yes.
Yeah. Good afternoon, everyone. I'm, definitely honored to join Paul here and to join you all. So my name is Azim Udin. I'm a principal cloud solution architect in Microsoft, based out of in Dallas. And I have been with Microsoft for almost over 19 years. I understand it's too long of a time for many of you, but I'm here and I love this company. Have been with Microsoft, worked in a couple of different roles, worked in support escalation, consulting, customer engineering, and now in customer success. I'm dedicated to MongoDB as part of our partnership. So if you have any questions around MongoDB and Microsoft integrations and the ecosystems that are working together, I'm here to help you throughout your journey. Again, be it POC, architecture, envisioning, all the way to, optimization and production delivery and things. So I'm happy to be here and then happy to present and share some learnings with you today.
Thank you. To finish, my role at MongoDB is partner solutions architect for the Microsoft partnership. So I manage all the technical aspects of the partnership for the Americas. And that's you name it, the kitchen sink. Anything that comes up that's technically related, I'm a part of. So today, I love these rooms. This is, as I mentioned, my favorite audience because sometimes it's 50, 100, 200 people and you just really can't engage. So I would like to keep it really engaging. So please, let's interact. Let's have a discussion. I don't want to talk at you. I've been to a lot of these. I've fallen asleep at a lot of them. So I'm always very, very sensitive to, okay, I'm in front of an audience. You guys have taken some precious time out of your evening to come here and learn. So I want to make sure that I deliver that. So there's some paths that I can't go down, obviously, and I will admit it. Because there's so much but if I can't answer your question, I will find a way. We can exchange information, LinkedIn, email, and I can get you the answers. So I do my best. So you can take me in various directions. But today, what I put together, and when I was thinking about what to present, so I wanted to help you understand. So how many here have experience with MongoDB? Okay. And so if I were to talk about that experience, is it between a 7, if you would rate yourself proficient in MongoDB, would it be a hands up still 7 to 8? Like on a proficiency of like a scale of 10, sorry, 7 to 8, I was at 10, sorry.
It's all good.
You guys up there, or would you score yourself kind of mid-level, somewhat beginner? Good. Favorite audience, because it's always hard to present to people that have been doing Mongo for 10 years, for example. And then the other question I have is, Agentic AI, have any of you built an AI agent so far? Same folks. Okay, great. And would you rate yourself above a 7 out of 10 in building AI agents, or would you rate yourself below? So 7 out of 10, put yourself up there. Wow. That's okay. And really, so pretty novice in the MongoDB side, right? Is that fair to say? And novice on the Agentic AI side. Great. So this is the presentation for you, because what I wanted to do is I'm not going to deep dive into, I can go somewhat deeper. I am not an Agentic AI expert. Just the word expert alone just makes me cringe. It's so difficult in our world right now to be an expert at anything. And if you're not in it day to day, so my Agentic AI work is in the evenings. It's not part of my day job, so it's when I can catch some time in the evenings and weekends. I dabble and try to build an agent and work with it and work with MongoDB. So I have some experience and some orientation with it, but not an expert by any stretch of the imagination. So on the MongoDB side, obviously a little stronger, have some experience there. So what I put together is giving you somewhat of an overview in an agentic system so we can all level set and understand what an agentic system is, so that we can start understanding. And my angle, what I'm interested in is data. Obviously, MongoDB is a database, so I'm interested in the data aspects and what an agentic AI system has or requirements or will necessitate out of a database system. So that's why I'm here today. I have so much to talk about when it comes to that. So what I did is I found some highlights, and I'll discuss some of these highlights with you. And then what I've done is something a little unorthodox. In the deck, you will see some slides with a QR code. So if you have your cameras, your phones, get them ready so that you can take a picture. And then if you're interested in that subject, you can then go and do a deeper dive. And behind that QR code has a URL to help you explore it further. So because what I'm doing is I'm trying to give you kind of the brain candy, kind of an orientation, get you somewhat started with this is what you need to be thinking about, and these are the areas that you can concentrate further if you're interested in the subject. Fair enough? Okay, any questions? Anything so far? All good? Okay. All right. So, start with the questions. So if you're writing an agentic system, right, is your data store truly ready for an agentic system at scale, right? These are the questions that we need to ask ourselves. And we need to understand, what does that mean? So that's really the theme of the presentation, is when you're looking at building these new systems, right? And we've heard of, I don't know how much of you are connected with Build and you watched the Build, the Build was in May this year, watched a lot of videos, it was phenomenal. And then Ignite, I participate in both on there. We have presented those shows. So I'm very plugged in, and I don't know if you've heard Satya Nadella and you've heard others, and the NVIDIA CEO, I never remember his name, is saying that, systems, as we know them today, SaaS systems, enterprise systems are dead. So of course, sure, and we're all figuring it out. We all know that this is a very quick, things are kind of reminds me of the HTML days when trying to do web development, figure out Ajax and what was going to be the standard. Quite similar, right? So we're still figuring out what this is going to look like. But one thing I do know for sure, and I think most of you will agree, is that it's going to happen. It's going to evolve. It's happening. The potential is there. So what does that mean when it comes from a data perspective when you're building these systems? So I'll start by addressing what I have been exposed and my understanding. So please, again, it's my understanding of an agentic system. It's the way I perceive it. But I literally, we have a very, very cool group. It's we have our AI office hours. So the brightest people in our company that are search experts, AI experts, have a session on Wednesdays, a.m. Central, and I joined them, and none of them can agree. It's like land change sucks. This is, so it's just interesting to watch them, and none of them agree on the definition. So this is my definition, right? So an agentic system is essentially one or more agents, right, that can essentially reason and then take action on that reasoning, and then also adapt real time to improve and to better reason, right? So this is when we look at that, what does that remind you of? Obviously, I think we all know that what an AI agents or agentic systems are, they're really kind of replacing the human element, right? So in systems, yes.
Paul, thanks for that definition. And I wanted to add a little bit more. So those agent, the agent is autonomously making decision without human interaction. That's another.
Yes, I missed the word autonomous.
Yes, thank you.
It's in my script and I missed it, so thank you.
All right.
And more of that, please. Like, please inject and say, hey, I heard, let's just have some fun here and learn together, because I'd love to learn from you too. So an example of that could be, right? So we've got, and I've tried to find a simple example, a greeting agent. So now we have this agent that then takes in the information, right? So there could be, from a greeting perspective, there could have been an email sent. It analyzes that email. And then what it does is it can then leverage a sentiment agent. So this is, when you think about these agentic systems, what you see is they're trying to solve very small problems, right? So I'm sorry, I'm trying to think of a technology that's quite similar where you break down. Yeah, I'm going. But so specialize. Don't try to do too much. When you generalize too much, it's too hard. So then you'll have that. It can also leverage a history agent. So then understand the customer history, so it can do that, right? So then it goes and sends, and then this can then go to an adaptation. So we talked about adapting in real time. So that agent can then adapt, so it can respond based on sentiment and history, take those. So they're all working together to be able to come up with a decision, and then it can then return something to the end user. So it's not just this one thing that does it all, right? It's a host of kind of a working together. So more specifically now, let's drill in to what an agent is. And this is where Kim will come in here. And I had some fun here. I call him Sparky, AI agent Sparky.
No one wants to call him Hal.
Yeah, that's right. That's right. So Sparky's kind of fun. So we talked about, so I'm going to break it down into various elements. And again, there's more. So there's always, but just kind of give you an orientation on what it is. So it starts with its perception. It needs to perceive something. And what it does is it uses data. You can use text, audio, images, any other data format. So it looks at it and is able to derive some type of a perception of what it's observing, right? So there's a perception there. And then as a result, then there's planning. So there's going to be essentially a reflection. So you're starting to see now that your GPTs of the world and your Anthropics and whatnot, that there's reasoning coming from agents that you can look at it and it's really watch it reason. So there's a chain of thought. Literally, it'll take and decompose what it's doing, analyze it, and then essentially have some sort of a reaction. It's another kind of a big bucket type of thing. And of course, there's a lot of complexity behind each one of these. And then the other aspect that's important is it has a suite of tools that it can leverage, right? So you see them. It was interesting when, you show a presentation like this. I had an earlier version, and you didn't have all the features in GPT that you see today, where you can go search the web and whatnot. It used to be plugins way back. But now it's, you see them where you can say, hey, I want you to search the web. I want you to go to an MCP server now, have just recently emerged. So all that. So it has these tools. So there's this tools in the tool set that you can configure, and then it knows just based on the conditions, the right tool to call. You're not going to ask it. You're not going to guide it. It's not going to be an if-else statement. It's going to say, hey, based on what I've just analyzed from a large language model, from a reasoning model, that from doing planning and its perception and planning, it'll go ahead and leverage one or many tools to do what it needs to do. And then also, probably more importantly, and this is one of the challenges that we see the most in our AI projects with our customers, is, the short-term memory is one, but then the long-term memory, right? So we do real well. So you think about what these agents are doing. They're looking to do what we do some of the tasks that we're able to accomplish in reason tools, and they need to do it. But we have this long-term memory. We have this phenomenal thing called long-term memory. And the stronger your long-term memory, the more effective you are as a human being. So if you've analyzed the people that we know that are hyper intelligent or hyper performers, and the people that have built multiple companies, they have incredible ability to do what we call deep learning. And the deep learning is that they learn, they can remember, and as a result, they know physics, they know this, they know biology, they know history, and they can take all these connections and create something new. But it was a derivative of all of this, right? Leonardo da Vinci being a great example, right? Artist, all that, and then he was a genius. So this is what we're trying to also get out of, and we need out of our agents. So that takes historical information memory for it to be able to learn and hold on to that learning. So that's somewhat problematic. So when we start getting into the MongoDB story, and I'll go into what MongoDB is. But one of the things that agentic systems do is they have different types of data, and there's more than this, but I'm going to address what I consider the top 4. But there's interactive data, right? Chat history. I don't know how many of you have asked GPT. You probably all use GPT, I'm sure. And you've asked it, hey, tell what do you know about me? Have you tried that query yet? Kind of freaky. It's like, oh, you're this and that. So
Does anyone not use ChatGPT? Yeah, figured. Okay, that's an easier question to ask.
yeah, and so a friend of mine, I didn't even know I was doing it at the time, and a friend of mine turned me onto it. So I asked. It was very nice to me. It didn't want me to cancel the payment that I send every month. Obviously.
What knows about you is you keep paying, and so please keep paying.
Yeah.
That was the okay. Good.
And if you give it $200 a month, it's even more charge.
It likes you even more, right?
Even more. It's a lot nicer.
Interesting.
Yeah. So, right, the more interactive data I have, right, the more information I can process. So if I understand, for instance, what we just talked about, the user profile and chat history, I can help put things into better context. So that data is important to retain in an agentic system. Right. Makes sense? We all agree? And then the other aspect is, right, we just showed what an agentic system is, and that was a very, very simple system. You can imagine where there's going to be, and we're talking about billions of agents out there, right? Not in one solution, of course, but there's orchestration. So there's agents having to communicate. So we saw just a little model, and if you're thinking about having to orchestrate and handle this communication, there's data involved in that, right? So what you're starting to see is that when you look at these agentic systems, and then there's agent state data, so current tasks, and the progress tracking what it's doing. And then last but not least, you'll want to track its behavior. So one of the things that's very important, and maybe Kim, you can help me with this term because I just heard it recently and I didn't lock it in, which is a way of saying that you're check stepping your agent. So we call it unit test, right, in the development world, but it's a form of unit test for this agentic system. So you're testing your agents, and then there's a way of doing it, and there's a term, they're coming out with these terms every week, but there's something behind that. So you want to look at its behavior, you want to look at its success metrics and whatnot, so that this thing isn't going astray, making decisions, putting extra zeros to paychecks, all that fun stuff, right? So I think you get the feel here where we build an agentic system, and when you start doing one, you'll see that your data is going to grow, because in order for it to do what it needs to do effectively, you need this additional data. So not only are you dealing with the data that you want to process, right? I would consider the knowledge, the foundational data, but now you're generating all this other metadata, this additional data to keep the system healthy and operating well. So storage, right? And then what is that data? I have some really, really cool Mongo socks. I am kicking myself in the butt because first of all, my wife yells at me because there's a big box in the closet. I went to a trade show and it was local and they said, please take this. They didn't want to ship it back to New York. And I have this big box of socks and they're really cool Mongo socks. And I should have brought them to the event, but
Well, you have to mail, now you've called it out.
I know I called
So
it.
now everyone's excited. We're all waiting, okay, we want the socks, Paul.
Because I feel bad because I
Okay.
would just.
So you're gonna have to FedEx them.
And do.
There we go, there it is,
New subject.
complete with sock.
I have a question. So when we're looking at this data, right, what format is it in generally? Would you say? First hand up. Don't be shy, please.
It's some kind of database usually.
And the structure of the data. So for instance, is it format or what we're seeing a lot of when we see, for instance,
Jason?
yes, the language of APIs, right? Because a lot of this API, and if you look at MPC. So yeah, so it is, I speak JSON, right? So agentic systems consume JSON. They love JSON. And why? Well, we'll go into, so here's a thing, if you're interested, it's also a test to see if anyone's actually interested in my presentation. So if no cameras go up, then I know that I'm bombing. So, so I'll hold it there for just a minute. This is a little write-up. So we have a couple of folks at MongoDB that are quite proficient. And I found this as being somewhat of a good starter source to read an article on agentic, and then you can take it, because I feel like I dig through so much information and I get different stories. But we have a gentleman called Richmond who is really, really quite, he's a good teacher, and he presents it in a way that's digestible that can help you take it to the next level. So we'll get there in a minute. But so when we think of an agentic system, and you know, we're starting to get into the data store, what you need to consider, what are the consideration of your data store when you're building these types of systems, right? So one of the things is adaptability, because we saw the different formats. So your data is going to be changing, right? And if it's JSON, JSON is conducive to change. It encourages change, right? So because it's so readable, it's easy to work with. So you want something adaptable. So you're going to want a system that is able to take in various forms of data without too much headache. Security, of course, right? More so than ever, because now you're going to have these systems that are literally eventually going to be responsible for some really, really scary stuff. You're going to want this to be secure. So need I say more? Accuracy, right? So one of the things that's holding back agentic, so our customers, for example, and we'll talk about some of our technology, but our customers were seeing that everyone thought there'd be so much more of this AI out there, but we're seeing it stall because it's non-deterministic. So I don't know how many of you have, yeah, right? So I was working with one this weekend. I wrote a little AI agent because I'm terrible with names, so bad with names, and I'm done being terrible with names. So I learned a system where you use mnemonics, right? So what you do is you take a name, create an image of it, and then some type of an image, and then you put it on a person's face based on a facial characteristic. Well, the hard part is the mnemonic. So I wrote this little agent that would take in a name and come up, I'll make a mnemonic based on certain rules, right? And oh my God, the variations that I would get from the LLM was so crazy. You know, sometimes it would do a wonderful job, and then I would put in the same name, and then it was just completely like a train wreck. So there's non-determinate. So we're so used to deterministic systems, they're non-deterministic. So we want things to be more accurate. especially when you get the minute. And then performance, always performance, right? And none of these are, but I'm just finding that they get underlined even more with these. Systems are going to be taking over quite a bit. Any questions on this? And then I just made it really cute because now everyone wants their systems.
Page 7.
There you go.
Well, now.
The first time I was able to do one of these, I see these presentations all my life and I'm like, I was able to create one. So I'm very proud of myself. The little things. So let's talk about adaptability. And this is where we start diving into MongoDB. So what do we have here? A JSON document. We've all seen them. We're all familiar. And so we looked at this JSON document, and I don't know how many of you have taken a JSON and inserted into a relational database and gone through that exercise, right? You got a couple of options, right? You can also get very clever. Some of the smarter people have a way of being able to create a table structure, and then they can rehydrate it very cleverly, or they just stuff it into a field that was offered to them through, and it's all there, and then you need to keep parsing it and whatnot. So those are your options. And nothing against relational databases, but I'm not here to beat them up. I made a career out of working with relational databases, very here. But to me, my father always told me the right tool for the right job, right? So if you're trying to do a project, choose the right tool. So don't try to use a flathead for a Phillips type screw. So when we look at this, right, the representation on the right-hand side is the relational representation of that data, right? So we see the appeal. I don't have to sell, I'm sure, this audience on the appeal of JSON and why because it's so readable. I could take the left-hand side and have my wife, who has absolutely no knack for technology, and say, what is that data on the left? And she would go, oh, I know what that is. And if I showed her that data on the right and said, please, and she would say, stop wasting my time. So, this is why JSON has become so popular, and databases that have document model stores are becoming more and more successful. And in fact, Satya was saying, and also Scott Guthrie at one of the presentations, that the data stores for the modern workloads, which is AI per se, and it's their opinion. We like their opinion, but they say that the document model is conducive for AI type applications for the reasons that we talked about. The dynamics of data is forever changing. So, but trying to take that and store that into that is kind of might spark you a little, why would you do that, right? So this is where, when you go, right, from a MongoDB perspective and you look at it, now we have that same data on the left-hand side. And what I have here is a snapshot. Hopefully you can read that. I can't see the screen.
Yeah, I was just about reading.
Cool. So I am showing you a document. This is a snapshot of our Atlas UI. So Atlas is our managed version of MongoDB. And this is literally looking at a document in MongoDB. So you go, and you can deal with it as is, right? So if you've got a lot of JSON to work with, of course, it makes sense to be able to have a database that can handle it well, right? Now, why is there resistance to the document model? Why not? So the number one thing that we see is I've been doing SQL for 20 years. I know it well, and why the hell would I change? And that is, remember I mentioned my by-class project? That was my buddy I hired, and he heads up, he heads up a team at a startup for logistics. So shipping, what's that called when you do the shipping logistics? And he does predictive models to see if there's any supply chain. So supply chain management, he does predictive analytics to see if there's something wrong in the supply chain. So you can imagine business went through the roof after COVID when they found a supply chain issue. And he does a lot of these analytics. And I'm like, why don't you use Mongo? And he's a veteran, and that's what he told me. So my best friend won't use MongoDB because he is a veteran of SQL. That's what he loves to do. So it is what it is. But who are our adopters? People out of college, and those that are out of college, maybe over here, maybe even in elementary school, high school. but they get taught, right? So you have the, the different tools that are given to you, that always have MongoDB to work with. So a lot of our adopters are some of the early people coming into the career.
See, but this data, it has a field name and then the data. It looks very much like a relational data you would use,
Yeah, and in a structure,
It's structured.
right, right. But a relational database is you have to, so good question. So I like the question because there's an actual, and if you have the ability to write it down, I don't have a link to his presentation. So we had a gentleman that works for us. His name is Rick Houlihan. Interesting background. He was very early on at Amazon. When Amazon was building their website, he was there. And what they found is relational databases weren't keeping up, and it was too expensive to run them for the things they were trying to do. They were doing a lot of innovative stuff. So they ended up coming up with document model, what they call non-SQL databases to do their stores. And he ran the black belt team for them. And he gives a presentation of, relational versus document model and why. And he really breaks down somewhat of the physics behind it, right? So when I go back to this structure here, I have to do a join. So if you've done a physical join, or you've actually, I wrote a database in a past life, there's IOPS. So there's some IOPS for every one of those joins. So that's a cost. There's a CPU engagement, right? So if I want to pull this and hydrate it, and then there's a compute to be able to turn it back into this JSON to pass it on to the next step. There's some compute there where if I were to retrieve this document out and I wanted to use it, I just do a single fetch and everything comes with it. No additional IOPS, no additional. So if you look at it, it's just raw science that you reduce CPU, reduce IOPS, you will have a faster retrieval if you're working with a document model.
If you've got hundreds of thousands of documents and you want a particular one, does it have a key structure and a linked list and a binary tree or anything to go
It has an
get it?
index, yes. And then every document comes with, you see that ID there?
Yes.
Up there? I didn't generate that. So if you have a unique ID, every single document has a unique ID that's generated. And then, so that obviously is indexed automatically. And then, of course, you can index all your fields as you want. So.
Yeah, I've got a question. So could you go back to that relational diagram that you have? So like I first saw this in the 90s, right? It's 2025. Why would anyone creating a new application use this old junk? I don't know of a reason why you'd want to do it this way instead of the document format. Is there one?
No.
Yeah, that's what I think. It's old. We wouldn't use that old junk, right? Right? I think.
The applications where the relational model still is the better fit is analytical workloads, right?
So like data warehouses, you mean?
Yeah. Data
So
warehouse.
star schemas?
Yes.
Okay.
Delta Parquet, Fabric,
Right.
where
Okay.
there isn't really any structure. You're getting data from everywhere, and the way that the way it's being stored is not. You don't necessarily understand its structure, right? So it's unstructured and not like what we call unstructured now, because now it's muddying the waters with PDFs and how LLMs deal with unstructured data, but. It's just, you're not anticipating how you're going to use that data. So you need to have it stored in a special Delta Parquet format that's optimized for, I don't know what I'm going to do with this data. But if you have structured data, which as we see for these AI agents and some of the data elements that it deals with, they're very structured. They have to be structured. I need to know that was that was a prompt that was sent. That was a text that was sent. This is an orchestration package that I'm sending you. So anyway, so it's, again, there are still a lot of people that have been, as I mentioned, have a lot of lengthy experience with SQL and working with it. What we're doing is we're simulating a document model And really it's a SQL-based storage, and they're eliminating all the complexity of having to do the hydrate and rehydrate. It's kind of like your ORM per se, right? So go ahead.
Yeah, we use a lot of that at work, and it's mandated by the vendor. So you have the option between Oracle or SQL Server.
That's right.
And get creative with that.
That's right. Yes. But again,
That's a problem. That's a problem.
you know, if Satya is right, if these great minds, and it's not just him, you know, video after video that I listen to and the articles I read, is that this is going to change. These agentic systems are coming. It's a different way. And, you know, we've been building our SaaS systems the same way for a long time, right? So there is change required. So there's going to be a modernization of our systems, because if you can write a system, like your software that runs your corporation, and I hate saying this, but it is the reality. And if you have 1,000 employees, but I can rearrange and I can automate your business with this new technology, and I can take you down to 100 employees, as a business owner, you're going to do it. And if you don't, and you choose not to, and all your competitors, and we know, especially in the US, highly competitive market, man, more than ever. I've owned businesses, I've started businesses. You know, for every one of you, there's 1,000 others that are trying to do what you're trying to do and trying to get the same customer. It's very, very difficult out there. It's getting easier and easier to do a startup. And as a result, you need to be very competitive. If you don't compete, you're out. And we've seen companies, you know, Sears and others, just talking about some of the older business, but you see now today that if you're not keeping out, you're out, which is flip. So we're going to see this wave of modernization. It's going to happen. So
Let me ask you a question. If this data has a particular structure and you keep storing documents that are like this, if you had a document that was different, would you use a different MongoDB or simply put it in there and have something in the ID that would say, this is this kind of document, that's that kind of document?
so naturally what you're going to do is you're going to store so there's a concept of a database, and a table in MongoDB is called a collection. And then in the collection, you store the documents, right? So I'm going to be showing a hybrid search. I'm going to show free text search, I'm going to show vector search, and then I'm going to show a hybrid search, which we're doing a reciprocal rank fusion, where you can use the combination of a free text search and a semantic search, which is a vector search, together for higher accuracy. I'll be showing you a peek into the database. So, and the one I'll be doing, and it's, by the way, you can go to MongoDB Atlas, right? It's cloud.mongodb.com, and then we'll take you to our website, and you can sign in, and then you can get a free account, no credit card, nothing. And you'll get, I think it's 500 megabytes of storage space. And if you need 2 gigs, it's like $5 a month, $2 a month. It's very, very low price. And you can get started. And one of the things that you'll see in the database that I'll be demoing, and I didn't have the link, I should put it on the slide or send it out, but there's a link to the project that I'll be demonstrating. And it's just all free. So we have all these sample databases that you can download and take a look at. So if you're interested, and the one that is quite popular is called the movie database. We call it MFlix, right? So in that movie database, I'm going to store the movies. So I would create a movies collection just naturally, right? And then if I were to have reviews, well, I could store the reviews in with the movies, but my documents could start getting quite large. So we do have lookups, so we can have reviews in a separate collection. So it just makes sense. The data that will be queried together should live together, right? That's just kind of the rule of database development. So, you know, that'll be accessed together, should live together. But sometimes you don't want to have your document, and we have a limit of about 16 megabytes, which is a large document, but still, it's just processing and efficiency. So you'd have your reviews in a reviews collection. You would have movie theater locations in a locations collection. So it just makes sense to do it. But in your movies, to answer your question, and I love your question. So for instance, let's say in this example, I won't talk about movies, I'll shift here because it's right in front of us. If I decide, I left out the middle name when I was building this database, right? So I wanted to now start storing documents with a middle name. no problem. I would just start inserting middle names and it's fine. So now I have documents that have a middle name, some don't. So you'll look at the document and there'll be no trace. It's not like there's a placeholder and it's empty. It's just not there. So there's a whole conversation about why that's powerful. So for instance, we have Cisco. Cisco has a ginormous catalog that has millions of dollars transacting, per minute. It's just incredible. And so their catalog system required updating. And when they needed to update it, it was so large, they had to take it down for a period of time and update. We've all seen it. The database is going to be down for maintenance and whatnot. So we wanted to solve that problem. So they ended up taking a MongoDB data store and using it and recreating their whole catalog in a mirror image. And they tested it for 6 months because it's very important for this catalog to work effectively. And what they did is then they made changes to the catalog. And there was no downtime at all while they were making changes on the Mongo side and there were in the relational, because if you need to add a column and you're going to have to reindex and all this and nulls and all the fun stuff that has to do, there's going to be some additional processing there and some downtime. So with the document model, you could literally in a collection put movies and theater locations and all that. You could. Why would you as a software engineer, right? And as a database developer, but you can't. So to your point, absolutely. So the fact though, but you can see the power when I'm capturing data and I decide to capture more data, I just send that document that has more data and I can decide later on if I want to go retro and go update and batch update my old, because maybe the middle names did come in. I want to go update those records. I could do that offline and just batch update that. So this is this flexibility. And this is why once you've worked with a document model, you can't go back to a relational. And I don't know how many of you, it was very, very popular in the 2000s. And I mentioned Jeffrey Palermo, who was my mentor. He taught me, continuous integration, taught me being able to learn unit tests behind your code. And then he also taught me domain-driven development. So when you're modeling your data store, you're modeling it to the domain that you're addressing it. Is that still being addressed? Is domain-driven development anything you're even familiar with? Probably not.
I'm not sure that's around anymore.
I think call it something different, right?
Microservices we use the
Yeah.
That's a popular field, like the modeling techniques. With
Yeah.
the microservices, you try to partition your microservices and you would follow some kind of a technique. So domain-driven design is like one of the
Because of the Microsoft, not Microsoft, sorry, the microservice
techniques.
action, it's called, it's a different principle. But I've always found when I was doing it, we weren't doing microservices back then, is that it was like a round peg. So I always felt like I was trying to get this data and I had to shove it in here and create these complex structures to then rehydrate and pull it back out. So that was a lot, but why this is important, why I'm spending so much time on it is because this is Mongo. Like I could talk to you about, because really what it is, it's not about MongoDB. It's about, do I want to go a document store route for my modern workloads, right?
Why would you not?
Yes. So if you, right. So Kim, if you're working with agentic systems and whatnot, much easier to work with a document model, depending on the type of system you're trying to build. It's just, for instance, as you're figuring it out as you go. And if you want to make a modification to that model. So let's say your chat history was capturing certain fields and now you're capturing additional fields. Fine, it's just there. You don't have to worry about it, no maintenance. And then those of you that have done a lot of database programming, we have this thing called the ORM. It's somewhat evaporating because I know Swing with Java is starting to put in a lot of that work for you, but it's doing it anyway. So there's still compute when it comes to that. But if I need to hydrate my object store from my database and my object store, my data is stored like this, which is quite similar to my object store that I'm going to have in my application. I can almost do a direct hydrate. So we've seen a lot of increase in velocity in development because you're not spending as much at this translation layer, right? In my day, when I was coding and writing my database systems, I spent a lot of time in my ORM and just making sure that, okay, I'm adding a field. So I got to add this, I got to add here. It's just quite cumbersome, where, and not spending time building systems that are delivering business value, right? At the end of the day, I want to focus on features of revenue, not the fact of not spending too much time and having to continually update and maintain my code to produce that feature. So these are all the things that drove the document model adoption. I'll get to in a minute. And then as a result, built MongoDB as a business. Yes.
Just out of curiosity, is there a way in Atlas to conclude what is the schema of the stuff that you have in the database? Like, for example, you would have a name, every name has a first and last, whether it exists or it's null or whatever, but you would know like the structure of the data that you have in the database.
Yes. So if you want to know kind of the overall structure of what it generally is, or
It's,
like the schema,
Define the
Yes.
schema.
it's,
so you can,
I was just thinking that the semi-structure data works in Mongo because MongoDB is flexible schema. So in your case, I don't know what this, are you looking for a schema or schemaless or flexible schema? But semi-structure works.
yeah. So for instance, talk about the ability, but really when you're building it, you would have a schema. You do want to have a set of rules behind your schema. And so you would build out, what you want that schema to look like. But if you needed to, so there's like a schema definition that can live in MongoDB that can help police the data that's coming in. Like, so for example, right, you want this field to be a certain type, right? All these controls. So typically, you wouldn't just go willy-nilly if you're doing enterprise type system. You would want to have a standard across your developers to have these rules. So you would have a schema. And as a result of developing your schema, right, you would know what the schema is, right? But what's great is that if you decide to add that field, you just add the schema, then start saving documents, and that's it. You don't have, and there's without any downtime.
Yeah, the willy-nilly part is what we're trying to avoid. We're trying to get to the entity relation diagram that you have on the right out of Atlas or
You can
something.
lock down your schema as much as I would say, I will say confidently that you can lock it down as much as you would your relational structure.
Is that typically done in the database as you would traditionally? Or is that done in the code that calls the database in a modern document store?
In the code.
Right. Because that's what's different, right? You were just asking about, you want an entity diagram defined by the database, which is the traditional pattern. Modern approach is database doesn't care. Your code is the thing that cares. So you moved it a layer, which is different.
Timon, right?
And where people, they want more transparency on what's going on. And, there was a lot of contention between, especially in my day, DBAs and developers, mortal enemies, right? So, what with rapid development and the advent of DevOps, modernizing kind of what a DBA used to do and whatnot, and you saw developers being more kind of like this DBA/developer, and that was another thing that helped embrace MongoDB, not MongoDB, but the document models, because it somewhat eliminates the need for DBA to a certain degree. I've got to be careful how I say that, but it was able to put a lot of control into the developer's hand, and for agile development environments, that was acceptable.
Any DBAs here?
Yeah.
Wondering?
Looking cautious.
Kim's a DBA. I'm not. Any
Well-
developers here? Yeah, there's a few developers.
Control over their
That might
environment.
be why I'm a bit biased against them, but I think.
I mean, I've been in shops where you can't make a change, like you have to, it can take months to get a change approved to one field, changing one field.
Yes,
That's the olden days.
so the JP Morgan Chase where I came from, that's true. 6 months, by the
Yeah.
way.
I was, because being in Austin, I was pretty close to the Dell catalog. So I had a very good friend of mine that was responsible for the Dell web catalog and literally take months just to make one very, very simple change. So they had to do it, right? But if you can find ways that you don't have to do it so that you can become more competitive, you'll have to do it, right? Because Amazon will find a way, or someone else will find a way, or the next Dell. This is the world we live in. It's like there's a lot of clever people, and now you've got this GPT or LLM PhD sitting next to you, helping you it's just a whole different world. Any questions on all this? I spent a lot of time on this slide, but
I'll throw one. I'll throw you one. So I see some latitude and longitude on there on your example data there, Paul.
Yeah.
Any geospatial features you want to tell us about?
so yeah, so we have probably I should have done a little bit more Mongo presentation. I wanted to just scratch the surface and then have you guys go explore.
You're good. We're going there because we're asking about it. It's fine.
But it's fine. We have 2 hours, but so we have this thing called the aggregation pipeline. So it's the way we do query, and it's way better illustrated with the slide. But I have a deck that I could pull up and we could talk through maybe once we finish if we want to huddle. But and it's essentially so. How many of you have worked with kind of a SQL, like have written stored procedures when you're building databases? So we're still there, right? So your stored procedures was kind of like SQL if you're doing it in the Microsoft world, right? And so you'd write your queries using SQL and using that structure. In Mongo, we have something called the Mongo query language, MQL, and your complex queries are done using aggregation pipelines. So it's all these aggregations that you do, and there's different stages. So it's kind of interesting. I don't know how many of you have worked with pipes, especially in a Linux prompt, where you're going to take a query, or you'll do a list, you do a direct list, and then you'll pipe it into a document perhaps, or pipe it into something, and it just pipes along. This is how queries work. So for instance, if I want to pull out all the last names, our first name's called Paul out of a database, and now it narrows it down from 1 million to 10,000, and now I want to sort them. The sort process, because it's in a different stage, will be only done on the 10,000 and whatnot. So it's very, very efficient, and you can decide how to around. But all that to say that pipeline has geospatial type capabilities and whatnot, so you can do near, and it's all built in native geospatial data types that you can manage, which makes it very, very powerful. And in fact, in the databases that I mentioned, there's special databases with geospatial information that you can play with. So we put data in those sample databases in a way that you can start testing a lot of the interesting features. So just to finish, right? That's part keeps happy. That doesn't have to deal with this complexity, right? So the point of this was like, if I'm dealing with a lot of JSON, would I want to store that information as is in a database, or do I want to do all this manipulation and then the additional CPU able to handle it? The question. So we'll address security. Security is always there. And so when we talk about Atlas from a security perspective, some of the features, this is more of the admin folks that tend to be more concerned about that. As a developer, I admit I was always quite ignorant to security and left it up to others to manage it. But, it does have everything. It checks all the boxes. So we have 10 of the largest banks in the world are using MongoDB. So obviously it's secure. So fine-grained access control, so you can lock it. We have various types of encryption. So we have encryption at rest, in transit, and also we have something called queryable encryption, which is interesting. So you can have a social security number that's encrypted, and you'll query it, and it will never decrypt itself. So never any traces in RAM or ever. So again, why do you care about that statement? Well, think about these agent systems that you're going to be building and some of the things that they're going to start doing autonomously. Back to Kim's point, the most important part of AI and Agentic is this autonomous. It is making decisions on its own. So if it's doing it, you want it to be, locked down. That information is going to be important, that it's not hanging around in RAM and whatnot. Of course, compliance, check the box. HIPAA, ISO, GDPR, and then auditing observability. If anything's happening, you want to get logs and access to logs, understand who's accessing the system when. All that is important. I'll skip through that security quick because I know that the more interesting stuff is coming, which is something called Atlas Search. So And again, I called out, so we have a lot of different features in Mongo, but what I wanted to call out are the ones that when you're going down your agentic path, and if you do choose to go a document model route, and then you choose to perhaps experiment with MongoDB store, there are some features that you're gonna benefit from and you're going to want to use. And one of them is Atlas search. So Atlas search is, who is familiar with Apache Lucene, right? So if you want to mimic Google search in your app, right? So you want to be able to do free text search, have it highlight, have it do type in it, all that fun stuff. Need not have to code that yourself. But Lucene, download it and leverage it. And that's what we did. We downloaded Lucene and we packaged it and turned it into our free text search under our licensing, and it's attached to the database. So when you're deciding to take a free text field, and I'll show you those indices in a bit, do the demo, and you text a free text field and you index it for free text search, you add another document, it'll automatically update that, that special index for free text search. So because a lot of people have used and have experienced using external data, external that are specialized in free text. Now you have to ETL, right? You have to take your data, ETL into specialized search, and then back and forth. So it's contained. So it's all managed for you. So this is where the unified platform comes in. And then you've got all those powerful, fuzzy search, multilingual, and all the relevance searching. And then vector search. So how many of you, not a lot of you in Mongo, so how many of you knew that vector search was part of the MongoDB database? Good. So vector search is part of it. Another thing vector search is called is semantic searching. So how many of you built a RAG application? Experimenting. How many of you want to know what RAG is? Okay. Retrieval augmentation generation is what it stands for, right? So what a vector search comes in is the retrieval part. So there are 3 steps in a RAG operation. So for example, you have all your notes from college, university, perhaps, right, in a digital format. And you're like, you know what, I'd like to be able to search it much like I do in LLM, right? But the LLM has no idea about your college notes. So in digital format. So you want to have that same LLM experience as you have anything that's been part of the actual GPT or whatever they indexed. So it's like use your own data. You're interested in using your own data. So what you would do is you would take that data, and we'll go into the details because it's funny. A lot of these sections are how we're present. But you would take that and you would chunk it. Because there's certain limitations. So trust me that you want to take maybe 500 characters or 1,000 characters. Okay. Then you would take that text and you would embedding. So we take that text and it would turn it into what we call a vector. And that is a mathematical, think of it as a representation of that text that a computer can understand. So what they've done is they've created this n-dimensional vector space. And they've indexed it in a way that dog, cat, so let's say, and I'm going to make this up, dog has 5.4 or 5.4 comma 6, and cat has 5.4.6 comma 8 or something. But and what it does is it puts to each other, so there's this connectivity to them, right? So what it's doing is it's taking that text and turning it into something that can help then do a similarity search to find, hey, that text is similar to that text, or when I'm searching for a term, it's going to be similar from a proximity perspective. There's a lot to read about it. I'm really just scratching the surface, but that's what it allows you to do. So what you would do is you would take a text, it would create an embedding, and then now that you have the vectors, then you can index them, and then you can now search. So what you would do is you would write a query, and you would say, I'm interested in the notes, one of your subject matters, let's say it was biology, and we're doing a certain, the structure of a cell and what I wrote about it. So you can just ask an English type question, right? A semantic question. And because they're all indexed, it knows it's going to take your text string, it's going to turn it into a vector because it'll only search vector to vector. going to turn it into a vector. It's going to go through your, for instance, if it's in MongoDB vector store, it's going to go through it. It's going to pull out the chunks that it finds are relevant. It's going to take those chunks and then you then use them. This is all you that has to code this, turn it into a prompt. And now you're sending relevant data. You're not sending all your notes because you might exhaust, the capacity that the GPT or the LLM can take. You're selling the relevant data. So the retrieval part is what you're doing with vector. Then you send it to the LLM via prompt to augment it. So now you're like, hey, I want you to take this and do what LLMs do. And then it will generate a response back, right? So let's say you're like, hey, I don't like the way my notes are formatted. I want my biology cell structure to come out in a certain format. I want you to bold. You can just run that query. It'll pull out the relevant ones that were cell structure. Something that simple. So it's being able to do an LLM experience on your own data. And you do that via vectors. Any clarification on that? Because very difficult to explain this topic without detailed slides. And we actually, at .local, we're going to have a .local in Dallas. We have .locals around the world. And that one presentation is exactly 1 hour that Henry Ruella gives. And it's just what I just explained in literally 5 minutes. So, but just an orientation, just understanding what it does. So vector stores, think of them as a way of being able to take your data and take the text and turn it into something a machine can then query semantically in a way, of a similar way, in fact, similarities. And we'll demonstrate a query exactly like that. So this is what vector search. So, always an advantage when you can store your vectors, again, much like free text search, the vectors are stored right in with your, so for instance, in a movie database, I'll open it up and you're going to see the movie database and the vector store will be right with it. And then quantization. Quantization is just a fancy term for compression. One of the things is that vectors searches have to be all in memory. And you can imagine when you have 1 billion records, where that can be, well, there's ways of compressing those vectors so you can put more of them into memory without losing accuracy. So what is similar to that in our world that we deal with media every day? MPEG, same thing, right? So we're able to compress a movie and be able to not lose much quality on compressing that movie. So this is, think of compressing vectors. So I know I'm getting into here and starting to see I think it's hot in the room too, but stick with me. I've got a demo. It'll light up here. Hybrid search. Why do you care? Does anyone want to answer why I care about hybrid search? I kind of touched on it earlier. Does anyone know what hybrid search is? Raise your hand what it is. No one in the room knows what hybrid search is, or is it everyone just being shy?
I've got no idea. Please tell us.
Okay. It's just, I'm curious because I thought it would be more, I thought more people, it's hard, right? Because I deal with this, it's all I talk about all day. And it's interesting because when I'm putting these presentations together, sometimes I assume knowledge, too much knowledge, and then I'm just going into advanced topics and I should start focusing still back on more foundational. So it's good to be in front of an audience like this. So hybrid search, and we'll demonstrate this, so stay with me here, is the ability to take one type of search and the other type of search, and one type of search would be free text. So there's a power in free text search, right? But there's also power in vector search, right? So if I can say, show me all the movies that are about the meaning of life and occur in outer space. Can you do that search effectively with a free text search? What results do you think that would bring you? 0, right? So, well, it could maybe a space, whatever, but the chances that it would give you, when I say result, is the result you're looking for. The fact that it would find you something from outer space with a meaning of life, it could be very difficult to find that, right? Because you're looking for a more thematic. So that's the power of semantic search. And so there's the ability to be able to use that and that. And you'll see, if you start reading about accuracy with agentic systems, hybrid search is coming up over and over and over again. And it's called reciprocal rank fusion. So it's a way of being able to take results from one, results from the other, and then best them so that you get the best result. So that's what a hybrid search is. So in the demo that I'll be giving you in just a minute, it's going to be It's going to be a free text search, and I'll show you what the results are. We're going to do a semantic search, and then we're going to do a rank fusion operation on that search. And then we'll see that our result that we're looking for will bubble up to the top because of the power of the two. I can average out and weigh them so that I can get the best of both worlds working for me to bring my result up. And this is what I talked about earlier, is that agentic systems struggle with accuracy. So, and this is why this hybrid search comes up. With me, right? Ready for a demo? You have to bear with me because doing live demos here are very dangerous. I'm going to narrate this one while it goes. It's an art form, people. It's to be able to have pre-recorded and go over it. But this here is a URL that I can send you. So you can download the source code to this. It literally just compiles and it can work. And what this is a hybrid search tester. So what you're able to do is you're able to just spin up MongoDB very easily, a cluster, and be able to do a search. And there's that URL that I'm talking about over here that you can it's there. You can always pull it back up or send it to you guys.
Or paste it in the chat of the meeting, maybe.
Yeah, I'll do that. But we're going to go to Atlas, back to Atlas, right? So I talk about this sample influx database that a lot of people play with. And one of the reasons why you play with it is that it naturally has the embeddings already built for you. So you can take this, download this database on your free cluster and instantly start using it as a vector store and start playing with vector search and doing the types of queries that I talked about. It's very cool. So this is this embedded movies here. That's the collection that actually has the embeddings in them. So what we did is we have a plot and the full plot, and then you'll see that it's got, for movies, over here, we've got the plot embedding. You see that array? And then we have a full plot embedding. So what I chose to do is I did full plot embedding for this demo because I had more text and I wanted to show the difference with accuracy. But you see, you've got the plots, and then there's the full plot and the plots that I just highlighted. And then they're essentially vector representations of that, the numeric representations that a computer knows how to do similarity search on. So for my text search, I've chosen to also search for in genres and also cast. And you'll see when I put my text search together and index it, how that comes together. And then you'll see here that I'm showing you an example of what a vector search looks, a vector embedding looks like. And it's over 1,536 floating digits, floating points to be able to represent that text that I indexed. Again, a whole subject on its own. So these are the two indexes that I've created. So I have one that's a search index, which is free text index. And then I have another one that you see called labeled vector search. So we're going to go see what it takes to create a vector search index. Super easy. That's all it is. All you have to do is put this command in, and you're the path, the type of similarity, and you can even hover over and tell you what those things mean. And then the type, which is going to be vector, and boom, you're ready to go. So literally a very, very short tutorial, and you would be able to do vector search on the movie database on your own using MongoDB, probably within, for a first timer, maybe an hour or less, and you're up and running, and you can start experiencing vector search for yourself. The other one here, you start seeing Lucene. So I did a compound index here. I did cast, full plot, genre, and title. All that means is that when I run my query, it's going to consider cast, full plot, and all these other fields as part of my query. So they're all going to be considered as free text searches. Okay, and then there's different text analyzer, there's multilingual, there's all this fun stuff. I just wanted to quickly show you what this index looks like. Again, this is all, and we'll have a hyperlink coming up that can help you go dive into this in more detail. What we'll do is we'll just get into the search now. So I want to do a security guard, armored truck robbery action. So this is what I'm looking for, right? I did my full text search. So you see where it's scored, right? Crime, it found action. So it found some of the terms that I'm looking for. But if I scroll down in a minute and I see my scores here, the movie I'm really looking for is Empire State. That one there is the armored truck security guard. That's the theme that I'm looking for. Right? I have a movie in mind And I know that security guard is armored truck, it's a robbery, it's action, and it's crime. But it's not coming up to the surface with a free text search. And this is something that we've experienced over and over again. Because I'm using too many terms, I'm trying to add some semantic querying to it. One of the things with this thing that's kind of cool, I know this looks a little overwhelming and we're not here to understand what this is, but this app that was written is you can actually look at your query and what it generated. And we saw that that was an aggregated pipeline. If I switch to a vector search, you see that it's starting to bring in, high-tech police surveillance attempts to take down a gang of ruthless bank robbers, but you see my entire state. And now the take, I know by the movie type that the take and Empire State are quite similar themselves. So not only did my Empire State go up a little higher, it also brought in movies that are kind of like Empire State and brought them closer. So now I'm going to do a reciprocal rank fusion search, which is a combination of, so it's, you see where it had the lexical, that's the free text search. And then there was a vector search and you see the scoring. So it took the 0.15, the 0.16, 0.31. So it's a combination of the two. And then my Empire State went to the top. So there's an example of why people are drawn to hybrid search is that I tried vector, I tried free text, and I didn't get to where I wanted to go. But when I did hybrid, in this case, I was able to get the result that I'm looking for, richer results. And the take, Empire State, the take, and crime stories are all quite relevant. They'd be considered. So you watch this, you might like this kind of situation. So that's hybrid search demonstrated. And then what you can do is one of the things that's powerful, and this is when it gets into a little more advanced, but you can decide to weight. So if you decide that you want to weight your free text search a little heavier for whatever reasons than your vector search for the scoring, when you change the weights, your results will change automatically. And then you can also do vice versa. You can decide to weight your vector store over your free text search and get a different result. So this one, we weighted the vector results. Now we're going to weight the free text search heavier. And you see that the sorting is changing because we're sorting automatically by score. So just a real quick overview on hybrid search. Again, think of it as brain candy. It's like, okay, I'm going to put this on my radar. I'm going to start getting more interested in agentic AI type systems. What is hybrid search? How do I get that done? So now you've seen it. You don't necessarily need to understand it. It's an effort to go and actually understand it. It's something you'll need to go explore. When it comes to performance, I'll go quickly here through these. One of the things that's important for scalability is when you're configuring your MongoDB instance, you're going to choose a server type. So you might have an M-Sneak, for instance, which has 16 CPUs and it has 32 gigs of RAM, blah, blah, blah. That's a server. Well, that could be good for your transactional data. Like your search data might need a more robust because you're going to do a lot of vector search, you're going to do a lot of free text search. Well, you don't want to have to go to an M200 just for search. What you can do is you can have your M60 that stays the same, that server instance that you're choosing, and you're paying whatever X dollar an hour for. And you can specify that your search nodes, or for instance, these searches that we've done, these indices, will live on a higher powered CPU, so that you can then boost up the power independently of also having to boost up your server where your transactions are going, data being stored. Now, France, let's say it's just storing data and it can be very low tier, but your search is everything you're doing. Then you can configure those independently. Well, that's a very, very important. You'll see if you end up getting into this. So that's what this is. That's a feature.
So Paul, this is if you deploy Atlas on VMs in Azure?
No, this is Atlas on Azure.
The SaaS offering. Okay.
This is the SaaS offering. Yes. So good question. So when if you go into the UI and you end up, you can independently configure and say, I want to configure my search nodes differently so that when your searches are occurring, they can occur in more robust machine. And we're seeing a lot of that. So when we put out, I'll give you a minute, when we put out a free text search and now putting out vector search, immediately we had scalability issues. Customers were throwing a lot of data at it. And they're like, I don't want to have to take my transactional system up to an M200 just to be able to do my searches. So being able to scale independently was able to give them the horsepower they wanted. And then it's isolation, right? So the CPU I'm using for search and RAM I'm using for search is not affecting my transaction. So they're completely independent of each other. So that's also very powerful. So it's all about, this is how you scale search.
Thank you for the presentation. So can you auto scale the engines to whether when it hits a certain city, you want to increase the CPU
Yes, you can.
for both engines?
You can.
And then on the back end, are they closely located at the same data center, or they could be different?
You can have different regions. So you can have it at whatever regions you want. So there's, I think we now support 43 regions in Azure. They can be anywhere around the world. They can be in close proximity. They can be, so it's all kinds of flexibility. We actually, when I go into the My MongoDB and I go into that presentation, I actually open up the dashboard for Atlas. I can a cluster and I show that, hey, I can have one of my nodes in California. I can have the other one on the East Coast. I can have some in Europe. It's whatever you want. So it's how, to answer your question, yes, we have auto scale. So you can set up your server to say, hey, if I end up hitting peak times, I want to scale up to higher tier, and when it slows down, automatically downscale. So we have that elastic, right? It's actually in one of these slides. And also regionalization is all up to you. It's all configurable. So this is a dedicated search node. So if there's anyone that is curious about this topic, as I mentioned, we'll find a way to send you information on hybrid search. Send you that link.
Already done. Our research link is in the chat. I added it to the meetup as well. The comments, so done.
Hybrid search for us is a new topic, so it's just something that just came out. Now you can do it yourself, but prior, when I was demonstrating in prior meetings a month ago, a couple weeks ago, it wasn't open to the general public. Now you can do it. So horizontal scaling is also something to consider. Is being able, so you have vertical scaling. So vertical scaling is I need more horsepower. So what do I do? Increase RAM, increase IOPS, increase CPU, vertical scaling. The founders of MongoDB were actually, you ever hear of the double click? Probably not as much now, but there used to be a lot, there's still a lot of click ads, right? Clickbait out there. They were bought by Google, but all the click ads really, they own the market. If to track track transactions, it was all done by this company called DoubleClick. And again, they had the same issue as Amazon. They're trying to store and scale, and it was costing them too much. So then they said, we need to redo a database. So they sold DoubleClick, and they're going to create a competitive version of DoubleClick and do a new database structure. So that's where they came out. And then the investor said, never mind this DoubleClick, this database, you're onto something. And the primary reason, so this is also a very important reason for your scaling, is it's called horizontal scaling. It's called sharding. It's taking your database and breaking it into smaller pieces, right? So I'll show in the illustration what that is. So we'll have shard A, we call them shards, right? B and C. So the way, and I don't want to get this to be too complex, and I'm already overloading it with information, but to be redundant, to have resiliency, we have 3 nodes. So you'll have 3 servers, right? If you put a cluster out, there'll be a primary and 2 secondaries. Why? If the primary goes out, there's 2 backup secondaries that can take over. That can happen within 4 seconds. So something happens to the primary, the secondaries are automatically mirroring as the primary data. It gets added to the primary, then it can fail over. So that's what you're seeing 3 boxes here. But more importantly, though, is that I could have chosen to have my billion records in one cluster if I wanted to, right? Not one cluster, but under one, essentially one shard is the way you call it. Under one cluster, but one shard. And it's perfectly fine. But what we found is that, I have to run that on an M80. Right? And again, the tiers, right? M0 to M200 price goes up.
Well, those must be Atlas. That's not Amazon. That's not Azure nodes, right? the Atlas
So their
concept?
Atlas nodes running on Azure,
Okay,
on
yeah.
Azure infrastructure.
You have names for them, M something.
Yeah, M is just, it's a Mongo tier.
Mongo, okay, yeah, thank you.
So it's
There's
just a way to say.
There's also, yeah, I was gonna say, there's also VMs in Azure, there's an M series, which that's, yeah, that was hence the confusion. Okay, Mongo.
Guess what? An M200 is more expensive than an M10 server. There you go, just by the numerics, right? So,
Is M100 the biggest, Paul?
no, we have an M400.
M400, okay, thank you.
So, so what we found is that, and this is what they found, is that we can have everything in one big database and it's got to run an M200. Or we can break it down into its logical pieces, or show some what's called partitioning, sharding, and it can run on an M60 or an M40. It's just incredible how that is because you're dividing the problem, right? Indices get smaller. So we'll show you this, how this is illustrated. So let's think of a bookstore. So titles, I have billion books. And so what I'm going to do is opposed to storing all in one database, I'm going to store A to F in this cluster, its own CPU, its own machine, its own. And I'm going to store in this cluster, not this cluster, sorry, this instance, this shard. Don't cluster, please. I'll back up. It's terrible. A lot of people would hiss at me at Mongo if I made that mistake. But you see where I'm segmenting information. So titles from N to Z, to start with, right? From G to M. So now I'm taking a big problem. I've taken it and broken it down into and distributed it, right? So now guess what happens if I go search for Harry Potter? Where am I going to go? Yes, which shard am I going to use to be able to bring up my Harry Potter? Which one? 8. So what we have at the top is the application. We have a driver. Think of it as an orchestrator. It knows where everything is. It knows where things are. So all it does is it knows to go query for Harry Potter in that. So instead of going through an index of 1 billion rows and have that index, of course, the index will be efficient, but my index is much smaller. So you understand that we're taking a large problem and breaking it down into logical pieces. That makes sense. Pretty straightforward. It's super powerful. So scaling, horizontal scaling. Question?
So do you get on a lot of debate how to spread your shards? Like,
Yes.
example, we split it here alphabetically. If I'm looking for a math book, it's gonna be non-fictional. So why wouldn't it be like different shards for that instead of searching all the books?
You shard for how you're going to query your database is the first principle that you use. But you have to be thoughtful of how to do it, to think through it.
So if I was going to look for all the books by J.K. Rowling, I would not shard that way. I would shard by author as opposed to shard by title of books.
No, you would still shard by the type. It depends. So you could, if you wanted to.
But you don't have to.
You don't have to, because what you're looking in is this fancy word called cardinality. So what you want to do is your sharding that you're going to choose, the field, and we call it the key that you're going to use, is going to help find you a way to distribute the data evenly. Ideally, we have what they call hotspots. So a lot of people out there that do sharding have issues with hotspots. What is a hotspot? What do you think a hotspot is? Anyone take a guess? There are no wrong answers. Right?
Shards way more populous.
Yep, happens all the time, right? So you want to be able to pick a way of being able to do it so that's why there's a way of just saying, I'm going to use a hash key. And it's just a fancy way of abstracting a lot of the decision of how you're going to, to want to configure your shards. It kind of does it for you. And what happens is it introduces hotspots because the data doesn't get balanced. So you get one node that's being hammered and others that are barely doing anything. So that's a problem. So with that said, yes, you have to be knowledgeable of your data and knowledgeable of how you're going to query it so that you can do it effectively. It's not as hard as I'm making it seem, because once you get comfortable with it, it becomes quite easy because a lot of customers leverage sharding, a lot of them. I mean, we have a large financial industry company that I was on the call with today, and I was advising them, and they're running their huge database, and they're running it on M30s, but they have 7 shards. So they found the sweet spot, and M30s are cheap and 7 shards. When I heard that you're running all of that, they're like, yeah, the power of sharding. So yeah, this is a course in its own, right? Multiple hours for understanding truly, but I wanted to give you the mind candy and say, write down sharding, write down so that when you're thinking about your agentic system, you're going to be tackling the databases, start thinking about horizontal scaling and whatnot. At least you have the knowledge and then you can go pursue it. So with that said, here's a link to give you additional documentation on horizontal sharding.
Question.
Scaling.
So does relevancy not take a hit in case you're sharding? Depends on how you're querying, but if we go back to the example, which we were searching for multiple terms, if the results are actually spread across different shards, how does the
So yeah. So think about what you're doing there though. So when I was doing that, I'm doing a free text search. So it's think of it as its own world, right? So an index, a free text index and a vector index are kind of different worlds on their own. And you know, that's where you know, the partitioning of that information and the way it's being handled is somewhat different than when you're doing, because when I was showing that example to your point, I think it's just a standard string, right? Just an equal type lookup. Or when you're using specialized indices, they have their own way of being able to index in a way to scale. So, and that's for instance, like search nodes, where you're leveraging search nodes, they're over partitioning. So the partitioning part will come into the retrieval, because if you think about it, when you're running your free text search, that text is indexed. So that search will happen in that text, but then it needs to go retrieve the record that it's looking for out of the database. You're trying to retrieve that document now, right? That we had that movie. So that in that case is where the sharding would come in, because there's that lookup that would be then directed that one shard as opposed to. So there's kind of 2 stages there. If you're doing an equal sign, so I want to look for a title, the titles that start with, like I want to alphabetically sort them or something like that. Then it would be very, very effective if I'm looking for titles between, right? Then we go direct into that database and leverage it and shard. If I'm trying to do a semantic query or a free text, and it's having to deal with this index, and it sorts out, then comes up with a compact list, and then it goes to the shard and retrieve what it needs. So you've done all the heavy lifting in the index, as opposed to when you're doing searches that go against the shard directly. Make sense?
Paul?
Yes.
Paul, I was wondering, we are.
Time check.
Yeah.
Yeah.
Yeah, I am. Yeah, I know. So I'm gonna skip this one, online archive. So it's just the way we talked about all this data being created, and you don't like chat history, right? You don't want to keep that online. So with MongoDB, for instance, you can automatically, when something comes in after 30 days, 90 days, whatever you want, you can automatically go to this archive, but it's still available for search. So it kind of gets offline, so your database sizes stay small, but it still can be considered for search if you needed to. And it's done through federation. So it's just a way to be able to find things. And what I'll just do is I'll just put the QR code, but it's something to look at. So what we're seeing is that, hey, I've got all this chat history. I don't want to keep it in my live database. I want it to be considered if I need to go fetch it. How would I do that? You would use a system called online archive. All right, thank you. So sorry, Azim, I went super long. But
Hey, no problem.
Azim will share with us. I'll let him introduce himself.
No problem. I think, Paul, your content is more interesting. And yeah, so hopefully, Kim, we are still good with time, right? I just
yeah,
have.
so, yeah, but basically we've got Ray here, and if Ray shuts his laptop, then that means we're out of time because he's bored. So he's the man. So we all watch Ray, and when Ray's bored, we're done. So a long way of saying, yeah, we're okay, Azim. It's okay. And
Okay,
no one has
no
left
problem.
yet. Yeah, everyone's still here, so we're okay
So Zim, I think.
for the moment.
Keep it out.
But yeah,
So
everyone,
do we have about 20 minutes?
30 minutes, yeah.
Yeah,
20,
yeah.
30 minutes.
20, 30 minutes. is fine.
Yeah.
Is that okay with you, Ray?
Hopefully, hopefully I'll be done in,
Ray's good with it, so we're fine.
15 minutes. Are you guys able to see my desktop? I'm sharing right now.
Yes.
And
Yeah, we can see it, Azim. You're good.
and then you are not seeing, I don't know if you're seeing the presenter notes or not. You're seeing.
Yeah, you need to flip it. We see presenter mode.
Okay. So, so thank you, Paul.
Azim?
We're seeing presenter
Yeah.
notes.
Yeah, you're seeing presenter notes. Okay. So yeah, how about now?
There we go. There it is.
Okay. Yeah. Yeah. So Paul, you showed some great content, like all of you, I'm also super excited to, learn about all these innovations in MongoDB Atlas to handle or tackle the next generation, Gen AI and agentic AI workloads. But to realize the full potential of all these innovations in MongoDB Atlas, you need a cloud platform such as Azure, which is a leader in industry, industry leader in AI, right? The partnership between MongoDB and Microsoft spans over a decade, and through our engineering collaboration, MongoDB Atlas is now deeply integrated into Microsoft Intelligent Data Platform, which basically enables you to realize the value of your unique data in MongoDB Atlas. So in my short 10-15 minutes presentation, I'll show you through a demo how MongoDB Atlas, through its vector search capabilities and integration with Azure AI Foundry, is helping solve enterprise AI challenges. So let's set the context, right? As we tap into the power of Gen AI, it's important to recognize that the technology also brings a set of challenges. Some of them are pretty complex. One of the most common is known as hallucination. I'm hoping many of you have heard of these, where a model generates inaccurate information, even given a set of clear inputs, right? And then there are issues of jailbreaks and prompt injection attacks, where someone is trying to manipulate the model through clever or malicious prompts. We also have to consider the risk of model generating harmful or biased content or even unsafe code, right? Or the model generating or reproducing copyrighted content, thereby raising legal and ethical concerns. So all that is to say is that while the possibilities of Gen AI are exciting, understanding these risks and building ways to mitigate is key to earning the trust of users who will be using that. So at Microsoft, we tackle these challenges through what we call our trustworthy AI framework, which is a set of principles, principles: fairness, reliability and safety, privacy and security, inclusiveness, accountability, and transparency. So these are not just a set of ideals. We have translated these principles into real actionable commitments, practical tools, and capabilities that you can use to build AI responsibly. And I'm not going to go over all these in detail, but basically what we call this is a defense in depth approach, layered protections working together to help you build AI systems that you can trust from the ground up. So now from the framework, let's talk about a real solution we provide. So one such solution in Microsoft overall AI solution stack is called AI Foundry. I'm hoping some of you have heard of these. So Azure AI Foundry is one unified platform which brings all the key components together in this platform to build enterprise-ready AI apps and agents at scale. First, you need access to the best models. Foundry offers a broad model catalog with options such as Azure OpenAI models, plus open source or partner models such as Llama 2 or Mistral. Next is ability to customize, right? The ability to fine-tune your models to meet your specific needs. Then comes knowledge integration. Connecting your AI to other Azure AI services, for example, Azure Machine Learning or Azure AI Content Safety or Azure AI Search, or even connecting your AI application to data sources such as MongoDB Atlas to ground your responses in real data. You can build intelligent multi-agent apps with just a few lines of code with support for A2A or MCP or other frameworks like LangChain. And then trust is super critical. So Foundry includes services like Azure AI Content Safety. And then you can monitor or evaluate your models using features like observability. So all of this is available through the tools that you are already using, such as Copilot Studio, Visual Studio, GitHub, and then you can deploy your models anywhere, whether it's in the cloud or on premises through Azure Arc or locally with Foundry Local. So one of the key things that we'll show in our demo is safety, and then so Azure AI Content Safety plays a critical role in keeping your Gen AI applications safe and responsible. It's built to detect and filter harmful content across different types of input, such as text, images, or even code. Out of the box, it provides filters for things like violence, hate speech, sexual content, and self-harm, but it doesn't stop here. You can also define your custom categories and block lists to meet the specific needs of your application or industry. It also includes prompt shields, which are designed to catch both direct and indirect prompt injection attacks. So best part is, Azure AI Content Safety provides dual layer protection by scanning both the input and the responses. And we'll show this in our demo. So let's basically, to bring everything that we have discussed together into focus, let's see how they all work together in real time. And just a heads up, you'll see these things in action in our demo that I'm going to show. It starts with the user prompt, which basically enters to your app front end, right? And then on your application backend, it combines these with the system messaging or grounding data. For example, your data that comes from MongoDB Atlas on Azure through vector search on your indexed content. This modified prompt is then passed to Azure AI Content Safety for things such as harm, PII, harmful content, hateful messages, things like that. And then if anything is flagged, Azure AI Content Safety can filter the prompt. That filtered prompt is then passed to your the model, which generates a response, right? The response, again, is passed back to Azure AI Content Safety for things like groundedness checking and then things like that, right? And that filter response is then passed to application. So this layered approach with protections on both prompt and output is a key part of building a safer, more trustworthy AI systems. So let's check all of these in the demo now. Let's build an intelligent app for Contoso camping using MongoDB Atlas and Azure AI Foundry. We'll start with the model catalog, which shows more than 11,000 models available. You can start with the leaderboard and compare models on metrics such as quality, cost, and throughput, or you can do a custom model comparison as well and then, and compare for cost versus quality. When you are happy with your model selection, you can select the model to choose. In our case, we have selected GPT 4.0 model for generation and GPT 4.0 model for generations, and then text embedding ADA 002 for embedding. And during deployment time, you can customize your model for token size, etc., and then some parameters you can take. So let's deploy, and in the interest of time, I've deployed all of these models. So now let's try these models that we have deployed in the playground. As you can see right now, I'm using a default system prompt. So asking for a Contoso product generates a generic response. It doesn't understand what product we are asking about. Let's try to fix this with MongoDB Atlas data and ground this. So in my products collection, I have actually the camping product details in the content field, and the vector, vector representation is in the embedding field. So the first step, as Paul was showing, you will create a vector search on the embedding field. And once we are done creating the vector search, we will then go back to Foundry to link this vector search by creating a vector index on the Foundry, right? So in this particular case, I'm going to create a pre-configured MongoDB Atlas connection and show some of the information that's needed. And then we're going to use the ADA 002 for embedding here, and then complete the rest of the steps. To save time, I'm going to use already created vector index that we are using for grounding our responses with MongoDB data. So let's try the same prompt that we used before, this time with the vector index that we created here, and try the same query that we created before. And this time we expect to get the response that is grounded on MongoDB Atlas data, a typical RAG application that Paul talked about. And you can verify that it is grounded in MongoDB data by clicking on the citations. Let's now try another query, basically an off-topic query to see how the model responds. Since the model is only grounded in MongoDB Atlas data, you can see that the response is generic and unhelpful. We will fix this now through a system message to guide the model, basically to respond politely to off-topic queries, and then route it to Contoso camping products. So with the system messaging now, you can see that it is kind of able to respond with a politely, saying that, hey, your query is off topic, and then routing you to Contoso camping products. Let's try to now improve the safety of our model through some safety system message, which can tackle harmful content, ungrounded content, copyrighted infringement, and jailbreaks. And let's try, once we apply this safety system message, let's try, and I apologize for the really hateful query here, just to show you how the functionality works. In this particular case, you can see that it's able to detect the hateful message, but it's not blocking it. Similar things happen with the jailbreak query that we are seeing. In both cases, it's able to detect the query, but it's not blocking it. Let's improve these safety through content filters. All models come with a default set of filters, but you can customize the filter and safety levels. In my case, I've defined two types of filters. One that blocks all sorts of violence and hate, and the other which kind of filters a subset of these. In our previous prompt, we used the filters that is a little bit more permissive. This time we are going to use the more stricter filter. And so with this filter, if we try the same hate query there, hate prompt, you will see that this time it blocks the prompt with a clear hate message, right? Same thing we will do with a jailbreak prompt as well. In this particular case, you will see that it's also blocking this prompt with a clear jailbreak indicator there. So this this improves the content safety while using flexibility. Let's wrap up our demo with model evaluation. You can use the baseline metrics, or you can use based on your own data. In my case, I've basically evaluated my model with my own data, which shows high fluency and low similarity, basically, and then strong safety. So that concludes my demo. Basically, all we wanted to show is that with MongoDB Atlas and Azure AI Foundry integration, you have the perfect recipe for creating enterprise-grade AI with safe and and scalability. So with this, I'm gonna hand over this to Paul. Paul, do you want me to bring the whole slide or?
Yeah, just build it out. Thanks.
Yes.
So really just to summarize, right, the considerations.
All the features that we talked about fall under the umbrella of the adaptability, security, accuracy. Look at those categories, and when you're evaluating your data store, whatever it is, just look at some of those boxes that were checked that we talked about under adaptability. Is it adaptable? Is it secure? Is it accurate? And is it performing for you? So thank you for your attention. It was a long haul. I'm glad that you were able to sit through it. Hopefully it was worth your drive and educational for you. Thank you.
Thank you, Paul. Any final questions for anyone here? All good. Ray still has his laptop open. So we have a moment, but okay, all right.
By the way, I have yet to have an AI give me a winning lottery number.
Okay, we'll see what we can do about that, Ray. So who learned something tonight? Yeah, me. I learned something. That was a good one. Thanks very much, everyone, for educating us. Next month, we have Kubernetes. So if anyone wants to learn something about Kubernetes, then how to use it, we have a member of the community here in Houston coming to talk about that on us. So thanks everyone for coming out, and thanks everyone online. Good to see you. Hope to see you next month. Thank you all.
Thank you.
Thank you all.